Good morning, good afternoon, good evening, wherever you may be watching this from. This is Cornelius Luvinda with another video. Addition Mathematics Calculus. Differentiation. This is the last question. We are finding the derivative using the gradient function from the first principle. And the question is like this. Y is equal to square root of x plus 4x squared. Then the formula is f prime of x is equal to f of x plus h minus f of x. We divide everything by x and by h rather. Then we take the limit as h approaches 0. So we're taking the limit as h approaches 0 is equal to, everywhere you can see x, we put x plus h. So square root of x plus h plus 4x plus h squared minus, you minus this function itself, minus square root of x plus 4x squared, like that. Then you divide everything by h. So we are taking the limit as h approaches 0 is equal to the square root of x plus h plus 4. You can expand this, x squared plus, how we expand is x times x is x squared, x times h is hx, times 2 is 2hx. So 2hx, you square the h, it is h squared. Then here we can just simplify, minus square root of x minus 4x squared. We divide throughout by our h. Then to continue, we can just clean up. We can clean up to continue. We are taking the limit as h approaches 0. It is equal to square root of x plus h plus 4x squared plus 8hx plus 4h squared minus square root of x minus 4x squared. We divide everything by h. Alright, upon us reaching this stage, we are going to simplify. We cancel the like terms, the ones that have opposite signs, of course. We have this 4x squared and this negative 4x squared. Therefore, we are going to take the limit as h approaches 0. When you reach this stage, everything that has the square root has to be grouped together. So it is going to be equal to square root of x plus h, you minus square root of x, like that, plus 8hx. Then you're going to add your 4h squared, like that. Then you divide by your h. Then at this point, what we are going to do is, since we have this here, the way it is, okay, let's split this. Let's divide each term by h. So we're going to divide these two terms by h as 1, then this as 1 and this as 1. So these two terms, we're going to divide them by h. So we're going, what I mean is this, the limit as h approaches 0 would be equal to square root of x plus h minus square root of x divided by h plus h, 8hx divided by h plus 4h squared divided by h, like that. We can simplify this. So we are taking the limit as h approaches 0. It is equal to square root of x plus h minus square root of x divided by h. Then if you simplify here, plus 8x plus 4h, there it is h, like that. So this is what we have. right here. So leaving it in this form is very important. So I've already divided each and every term by the h, which is very important. So we can clean up to make some space. We can clean up, and then this, we are going to keep it here. Then there is something very important to note. There is something we call conjugate. Conjugate. So in this question, it is a special question. We are going to conjugate in this question. We have square root of x plus h minus square root of x divided by h plus 8x plus 4h. This question here requires us to conjugate. It means that, for example, conjugating can be used to rationalize a denominator. We have maybe 1, you divide by square root of 2. To rationalize this denominator, we conjugate 1, or we do it like this. So we multiply by a special 1. Have you seen that one? So you have multiplied by what is here. Now conjugating is like multiplying by opposites, alright? The opposite of what you can see. So this is called rationalizing, then conjugating is something bit different. So, but anyways, this is the concept behind conjugating. Conjugating is the opposite. Rationalizing is just making the denominator a rational number. So this would mean to be square root of 2 divided by 2, because square root multiplied by square root gives you the whole number in the square root, like that. So conjugate. Alright. So here, we are going to get this part of the limit, this part right here. This part here, which is the square root of x plus h minus square root of x divided by h. We conjugate. Conjugate means multiplying by the opposite. So you saw as I was rationalizing that denominator, I was multiplying by the same denominator. Now conjugate. We still multiply the top and the bottom by something, but it's the opposite. Alright, there it was the same. Now here it's opposite. So it means to conjugate this fraction, we are going to multiply by square root of x plus h minus, square root of x, you divide by square root of x plus h plus square root of x. Now the thing about conjugating, it is that when you simplify this, it is still going to give you 1. It's going to give you 1. So here if you simplify, it should give you 1. Now the thing about conjugating, it is that this times this is going to give you what is in the square root. When you multiply the top and the bottom, it's going to give you something different, something that you can work with. That is why we conjugate. Because if we are to use this as in the limit, it would be very hard for us to manipulate. So it would be equal to square root of x plus h minus square root of x. You multiply by square root of x plus h plus square root of x. You divide by h multiplied by square root of x plus h plus square root of x, like that. Then at this stage we can simplify. Let's erase the top to create more space. We can simplify at this stage. So this, you multiply by this. When you multiply those, you're going to have x plus h. The reason being, square root of 3, you multiply by square root of 3. So what can you note? You're multiplying two sets, two numbers in square roots, like that have the same number. Okay, they have the same number. You're not multiplying square root of 5 times square root of 9 times square root of 5. That's different. But here they have the same number. The answer is 3. Simply because square root of 3 means 3 to the power 1 over 2 multiplied by 3 to the power 1 over 2. When the bases are the same, simply means you add the fractions, gives you 1, which is 3. So this is why I'm saying square root of x plus h multiplied by square root of x plus h is just x plus h. Then this you multiply by here. So it will be plus square root of x plus h multiplied by square root of x, like that. Then you minus square root of x plus h multiplied by square root of x. Then square root of x multiplied by square root of x is minus x. Then you divide everything, okay, by h. You multiply by square root of x plus h, then plus square root of x. So what have I done? I multiplied this by that. That's what I did. Okay. Then reaching at this point, what we are going to do is this. This square root of x plus h multiplied by square root of x is the same as this. They cancel out and they give you 0. So it would be equal to x plus h minus x. You divide by h multiplied by square root of x plus h multiplied by square root of x plus h plus square root of x, like that. That's what we are having. That and that will go, then we just get this and this. Okay. Then if you simplify that, you're going to have this and this will cancel out, giving you h. You divide by h square root of h, x plus h rather, plus square root of x. You have seen how it has become more possible to manipulate. This and this can cancel. It means we are going to have 1. You divide by square root of x plus h plus square root of x. And this is our simplified version of this part of the limit. So we conjugated. I hope that's clear. Just know when there's a square root, there is going to be need for you to conjugate. Otherwise, you are going to be stuck. Okay, so reaching that point in time, we now get this. The limit as h approaches 0 is equal to, instead of writing this, we are going to write this. 1 over square root of x plus h plus square root of x plus 8x plus 4h. We can now even erase and just answer accordingly. Since we have already divided each term by h, we can now use the limit. It is as h approaches 0. Everywhere you can see h, write 0. This would be equal to 1 you divide by square root of x plus 0 plus square root of x plus 8x plus 4, plus 4 multiplied by 0. This would be equal to 1 you divide by square root of x plus square root of x. Since this is 0, it will just remain as square root of x, then plus square root of x, then plus 8x, because this will give you 0. Therefore, f prime of x would be equal to 1 you divide by 2, you multiply by square root of x plus 8x as your final answer. So that is your derivative using the gradient function from the first principle for this question. Thank you so much for watching. This has been Cornelius Lubinda with another video. I'd like to also thank you for your support, and bye bye.